Topic 5, Objective 2. Solve a polynomial using the sum and difference of cubes formula. Alright, so these types of polynomials I'm going to show you in this video are a special type, whether they're a sum or a difference of cubes, or perfect cubes, to be more specific. You can still solve them the way that we've done in the past. You could graph them to see where they cross the x-axis, and then use synthetic division to get it down to a quadratic function, and then you could solve it from there. But this is just another process I want to show you. So to begin, these are the two formulas we're going to reference: the sum of cubes and the difference of cubes. Alright, so make note of that. Ideally for each one, the goal is going to be to identify, in this case they use x and y as their variables, so you're going to identify an x and a y for each of these. Alright, so just keep that in mind as we go. Before we begin an actual problem, I want to talk about perfect cubes to remember. Just the first 6, just to kind of be familiarized with what is a cube, or what is a perfect cube and why. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and 6 cubed is 216. Alright, so the perfect cubes I've written in blue. They are perfect cubes because if you take the cubed root of them, it would go back to the original number. So for example, let's do the cubed root of 64 is 4. So it's a perfect cube because if you take the cubed root, it breaks down to a whole number. Alright, so those, just familiarize yourself with those, and then you'll see those numbers pop up a lot in this practice and even in these videos. So I'm going to factor 2 different ones, and I'm going to factor and solve one of the 2 in this video. Alright, I'm going to do these 2 examples up here, and then I'll ask you to do these 2 down there on your own. So the first step is to identify the x and the y for the formulas. Alright, if you remember, I already said that we're going to be looking for an x and a y up here. Now the question I asked myself, if I was going to do a cubed minus 27, the biggest thing that jumps out at me is that it looks to be that 27 is a perfect cube. And that would say to me that I could potentially use this formula to factor and solve this. Alright? And the question I have to ask for step 1 in identifying the x and y is what's being cubed in each piece. Okay? A cubed minus 27, there's a piece right here and a piece right here. What is being cubed in each of those pieces? So the first one's easy. A is being cubed. It's just given to you that way. Now, in order to get 27, the number being cubed to get 27 is 3. So I'm going to put 3 down there. So it's going to be a little confusing because x is going to equal a variable. But in this case, the first piece is always my x, second piece is always my y. And x and y are always the pieces that are being cubed. So that's why I have to ask myself that question, what is being cubed? So in this case, x is a, my a right here, because that's what's being cubed in the first chunk, and y is 3, alright, because that's what's being cubed in the second chunk. So I've identified the x and the y for my formula. Now, it's a cubed minus 27, so I'm going to use this formula up here. X cubed minus y cubed equals x minus y times x squared plus xy plus y squared. So it's important to identify the x's and y's because now we're going to start, if you notice step 2 says to input the x and y terms into the formula itself. Alright? So if I do, this is step 1. If I do step 2, it's going to become, I'm going to input it into this piece of the formula. Alright, so it's going to become not x minus y anymore, but it's going to be, my x is a, so I'm going to put a minus my y, which is 3, times x squared, in this case it's a squared plus, now it says x times y, in that case it would be a times 3, but I always want to write the number before the variable, so it's going to be 3a, and then plus y squared. In this case, y squared, I'll put that in parentheses because we're going to actually have to do that math. Y squared, 3 was my y, so I put 3 in parentheses squared. All right, I could have jumped to 9, but I just wanted to show you that thought process. All right, so I'm going to rewrite everything, a minus 3 times a squared plus 3a, and then I actually have to do this math. 3 squared is 9, so plus 9. All right, I have factored it. That's what step 2 is. It's factoring by inputting them into the formula. So we have factored it to the point where now step 3 means technically I did step 3 square the numbers if needed. I did step 3 right there, so I'm technically done with step 3 as well. Now step 4 says set each factor equal to 0 and solve. In this case, this is a factor and this is a factor. I'm going to underline this piece in blue, if I can find that. Right there. That should look familiar to you. It is a quadratic trinomial. Now we have factored and solved quadratic trinomials using MACAB and the quadratic formula. You will never be able to factor this piece of this formula in the difference or sum of cubes. So now we would always have to use the quadratic formula to find the two solutions there. Here it's easy. I just set it equal to 0 and solve. A minus 3 equals 0. I plus 3 to both sides, so a would equal 3. There. But we would have to use the quadratic formula for this one. I'm not going to do that right now. Instead, I'm going to do steps 1 through 3 on the second example problem. And then I'm going to have you pause and try that process for your two problems down there. So just to show you another example, I'm going to do this one over here as well. In this case, it's the sum of cubes, so I'm going to use the first formula up here. And the first step is always the same. I'm going to identify the x and the y. And the question I have to ask myself in each piece, what is being cubed in order to get what exists in the function that's given to me. So 125x cubed. Please stay with me with this. 125, what number is being cubed in order to get 125? It is 5. All right, so this breaks down to a 5. And then if you notice, this x is also being cubed. All right, so I have to write 5x. So my x value of my formula, because if you remember, this is always the x, always the y. My x value is 5x. All right. Now the y value is just going to be a number. There's no variable with it. What is cubed? What number is cubed in order to get 64? And in this case, it is 4. 4 is being cubed. So my y value is 4. So I've identified the x and y's. Now I input them into the formula. All right. I'm going to use this piece of the formula. This just denotes the difference of cubes, or sum of cubes in this case, formula. But I'm going to input it into the x plus y times x squared minus xy plus y squared. So x plus y, so this is step 2. X plus y, in this case, it's going to be 5x plus 4. All right? And then times my x squared. In this case, I do have to put something in parentheses because there is a number with my x. So it is going to be 5x in parentheses and then squared like that. All right? That is an x. And then it was x squared right here. Now it's minus x times y and then plus y squared. So minus, and again, x times y, I want to put the numbers first. So 5x times 4. I can actually show that process. 5x times 4. And then minus, or I'm sorry, plus y squared. In this case, y is 4. And then I raise it to the power of 2. All right. I don't have to do anything to this piece, so I'm just going to drop that down. Plus 4. And this is step 3. This is what is very important to do in this process as well. And this is a mistake that a lot of students make when they're working through this, is they forget to actually do this math. I have two things that I have to raise to the power of 2, and then I also have to do this math right here. All right? So 5 squared is 25. X squared is just x squared. And then this math, 5x times 4, becomes minus 20x. And then this math, 4 squared is plus 16. And now I am done. I have factored it, all right? But in order to go as far as solving it, I would have to set each factor equal to 0 and solve, okay? So I'm going to do this, and I'm going to show you the math I use for the quadratic formula. But I'm just going to pause it, show my work, and then you can look at it and take a look to remind yourself of how to do the quadratic formula. But I'm not going to go about it step by step because you've already utilized the quadratic formula before. All right, but I'm actually going to solve number 3, show you the process for it, because I want you to solve this one down here for your practice, all right? All right, so I had gotten to this point, and then I went ahead and did step 4 for this example. Step 4, I solved this factor right here and got x equals negative 4/5. I set it equal to 0 and solve. And then I solved this piece, technically this factor, which is a quadratic trinomial. I solved that by using the quadratic formula. Here in purple are my steps for the quadratic formula, all right? I entered it in. It's opposite b plus or minus the square root of b squared minus 4ac all over 2a. And then I simplified the discriminant, which got to be here. I had the square root of negative 1200. I broke it down. That broke down into 20i radical 3 right here. So I had to write 20 plus or minus 20i radical 3 over 50. And then to get from 20, 20, and 50 to 2, 2, and 5, I divided all those pieces by 10. They all were divisible by 10. So my final answer, one of my solutions is x equals negative 4/5 here. And then the other two solutions are x equals 2 plus or minus 2i radical 3 over 5. And if you notice, it was, the highest power was 3. And I was looking for three solutions, and I found all 3. 1 right there and 2 right here. Good. Go ahead and pause the video then. Try to just factor this one. Get it into factor form, so get it into step 3 right here. And then for this one that I've starred, you're going to factor and solve. So you're going to take it all the way to step 4. So please pause it and try both of those, and then unpause it to check your understanding. At this point, you should have paused the video and tried these 2 examples on your own. The first one, u cubed plus 125, all I asked you to do is factor it. So you should have gotten what I got for step 3 down here. So please check your work with mine. It needs to look exactly like that. And then over here, the second example, 8x cubed minus 27. I took it to step 3, but then I asked you to factor it, which is step 3. So 2x minus 3 times 4x squared plus 6x plus 9. But then actually take it through to step 4. Set each factor equal to 0 and solve. So this factor, 2x minus 3, I did over here, and that's pretty simple. It's just a linear equation. I added 3 to both sides and divided by 2. And I got one solution right here. So I'm 1/3 of the way there. Now, 4x squared plus 6x plus 9, I needed to use the quadratic formula. And I showed that work in red, and then I showed how I simplified the discriminant right here in blue. All right? So I set it up right here. Then the discriminant was negative 108, so I had to break that down, and that broke down into 6i radical 3. So it was negative 6, or opposite 6, plus or minus 6i radical 3 all over 8. And then the 6, and the 8 are all divisible by 2, which then leads me to my final answer of negative 3 plus or minus 3i radical 3 all over 4. All right, so I found one solution right here and 2 solutions right there, which give me 3 solutions, and I was looking for 3 solutions, so I am done. If your work doesn't look like that, please raise your hand and I will come check it.